Here we can see normal operation of the PCV valve. Here we can see normal operation. We're going to specifically look at the commanded throttle position and the fuel trims and engine speed. When we remove the dipstick, it will introduce more air into the crankcase and through the PCV. As you can see, the throttle position increases, and it also changes our fuel trims as it sees a more lean condition.
So here we're going to demonstrate that there's no blow-by by removing the oil cap and putting this paper, and it should vacuum on the cap. As you can see, it is not bouncing.
Excessive flow.
Here's a quick diagram of the operation of the PCV valve. Here we can see how pressure in the crankcase will flow through the PCV valve and how vacuum will close the PCV valve.
Ready?
So here we have our scan tool data for variable valve timing. Here we have our RPMs, our VVT change angle 1 of bank 1, of bank 2, exhaust VVT, control duty ratio bank 1, exhaust ratio bank 2, VVT change angle bank 1, VVT change angle bank 2 for both the intakes. And this is just it running at idle, and then if you give it some throttle, you can see these go to about 0 degrees, and then these drop a little bit from advanced, as well as our intake right here.
Alright, here we're going to show some of the bidirectional controls of the VVT on the Toyota. Here we're going to control the intake VVTs on bank number 1 only, and here we can see the different PIDs for the normal conditions. And we're going to go to kind of its upper bound limit here. We change our duty cycle to 99%, and you can hear an audible change in how it ran and throttle. And now we can change to negative 99, and a definite audible change in how it ran. We go back to about normal duty cycle as it runs back to normal idling.
The EGR valve on the Buick operates in order to cool down cylinder temperatures to prevent NOx emission levels. This happens when cylinder temperatures exceed 116 degrees Celsius. This type of EGR valve is called a linear EGR valve. It consists of a valve position sensor cap, bobbin and coil assembly, valve pintle, primary pole piece, armature sleeve, armature and base assembly, inlet port, and outlet port. The EGR valve is operated based on certain operating conditions in order to prevent drivability concerns. The linear EGR valve is operated by the PCM and is high side driver controlled, a 12 volt pulse width modulated signal. The ground path is completed by turning on a separate driver within the PCM. Certain inputs that the EGR valve uses is the engine coolant temperature sensor, intake air temperature sensor, barometric pressure sensor, the MAP sensor, throttle position sensor, and mass airflow sensor. Diagnosis of the EGR system is mostly done by the PCM. This is done by monitoring the manifold absolute pressure sensor and monitoring when the EGR valve is open to see a predetermined increase in the MAP sensor reading. If it's not detected and this difference is out of spec, it will adjust a calibrated fail counter, and once it reaches a failed threshold, it will set a MIL and a DTC in the system.
So here I've got the scan tool data for the EGR. As you can see, right now we're at idle, so it's not on. But here is all the engine data for the EGR. That goes into evap. All right. So here I'm gonna give it some throttle. As you can see, nothing happened because EGR usually only starts during cruising speeds. Here we're testing the resistance across the EGR solenoid. Here we have it hooked up, and we get about 6.4 to 6.3 ohms. Here with the EGR sensor unplugged, we have a check engine light, as well as the EGR position sensor being at 0 instead of 0.86.